6.6 goes over solving equations involving rational expressions. With these rational expressions, we're working with fractions that have variables in the denominator and the numerator everywhere within them. If we look at these examples, the easiest way to do it is to get rid of the fractions. And by getting rid of those fractions, you're going to multiply the entire equation by your least common denominator out of every single term within the equation. So if we look at example 1, we're solving 1 over x plus 1 over 4 is equal to 1 over 6. So look at all of your denominators. Your least common denominator between all of these has to deal with the x, the 4, and the 6. So that's going to be 12x. If we multiply the entire equation by 12x, it will get rid of every single denominator and only will be working with those numerators or those whole numbers that are left over. So first fraction, you're going to multiply 12x by 1 over x. Then you have 12x times 1 over 4 and 12x times 1 over 6. We can simplify these. That x cancels out, so it's just 12 times 1, which is 12. The 12x times 1/4, the 4 becomes a 1. 12 becomes a 3, so it's 3x times 1, which is just 3x. And then on the other side of our equal sign, the 6 becomes a 1, making the 12 a 2. So 2x times 1 is just 2x. We then just solve for x. Get all of your x's on the same side. Get your constant on the other. So we're going to subtract 3x from each side here. We have 12x is equal to negative x. And then we want a positive, 12 is equal to negative x, not 12x. 12 is equal to negative x. We want a positive x, so we're going to divide each side by negative 1, making that x a positive, and we get that x is equal to negative 12. With any of these, just like every other equation that you solve for the variable, if you plug in your answer for the variable and you simplify, you should get a true statement if your answer is correct. For example 2, we have 10 over x plus 14 over x plus 2 is equal to 4. So our least common denominator here is going to be x times x plus 2. So we're going to take every single part within this equation and multiply it by x times x plus 2. So we're going to do x times x plus 2 times 10 over x. Then we're going to have x times x plus 2 times 14 over x plus 2. And x times x plus 2 times 4. For the x times x plus 2 times 10 over x, the x and the x cancel, so it's just 10 times x plus 2. For the x times x plus 2 times 14 over x plus 2, those x plus 2's cancel, so it's just x times 14. And on the other side of our equal sign, that x and that 4 are going to multiply to give us 4x, and we're going to multiply that by x plus 2. So from here, multiply. I'm going to distribute in that 10. We get 10x plus 20. The x times 14 is 14x. And then I'm going to distribute in the 4x. So 4x times x is 4x squared, and 4x times 2 is 8x. We have an x squared here, so we want everything on the same side of that x squared if it's positive. That 4 is positive, so we're going to move the 10x, the 14x, and the 20 over to the other side. We can combine like terms first to give us 24x plus 20 is equal to 4x squared plus 8x. That might make our lives a little easier. From here, we're going to subtract the 24x from each side. It is a like term to the 8x, so we'll combine those. We get 20 is equal to 4x squared. 8x minus 24x gives us negative 16x. From here, just move the 20 over, subtract it from each side. So we have 4x squared minus 16x minus 20 is equal to 0. You have to factor this since you have an x squared. You'll realize that you have a common factor between the 4x squared, the negative 16x, and the negative 20. They're all divisible by 4, so we're going to factor out a 4 to start with. So it's going to give us 4 times x squared minus 4x minus 5 is equal to 0. So you want your factors of -5 that add up to be a -4. It's going to be 1 and -5. So this just factors further to be 4 times x plus 1 times x minus 5 is equal to 0. From here, we're going to set each part equal to 0 and solve. So 4 is equal to 0, x plus 1 is equal to 0, and x minus 5 is equal to 0. If 4 is equal to 0, it's a false statement, so cross it out. Don't work with it. Forget about it. X plus 1 is equal to 0. Subtract the 1 from each side. You have that x is equal to -1. The x minus 5 is equal to 0. Add the 5 to each side. You get that x is equal to 5. Now, look back at your question. You have to make sure that your answers work with these. So if your answer gives you a 0 with any of the denominators, then you know that's not a solution. So you have to check these in order to make sure that they are definitely your answers. In this case, the -1 and the 5 will not give us a fraction that we can't work with, so we're good. Those two answers are perfect. For our next example, we are given 3 over x plus 6 over x minus 2 is equal to 12 over x squared minus 2x. Our least common denominator here is the x times x minus 2, because that x squared minus 2x factors out to be x times x minus 2. So we're going to multiply the entire equation by x times x minus 2. So we're going to have x times x minus 2 times 3 over x. We're also going to have x times x minus 2 times 6 over x minus 2, and x times x minus 2 times 12 over x times x minus 2. The x's cancel out, and you're just going to do 3 times x minus 2 for the first term. Next, you have the x minus 2's that cancel out, so you're just doing 6 times x for the second term. On the other side of that equal sign, the x times x minus 2 cancels out, so we just have 12. We're going to distribute in that 3 to get 3x minus 6 plus 6x is equal to 12. We combine our like terms to get 9x minus 6 is equal to 12. We move the 6 over by adding it to each side. We get 9x is equal to 18. And then we divide each side by the 9 to get that x is equal to 2. Now with this, you got to keep in mind, if I plug in 2 to any of these denominators, am I going to get a no solution fraction? 3 over 2, you can work with that. If we do 6 over 2 minus 2, that's 6 over 0, and you cannot have that. So this is, because it doesn't work, is called an extraneous solution. So technically, you don't have a solution for this one. Sometimes you will be given an equation that simplifies to where you have 2 answers and only one of them is an extraneous solution. Sometimes it'll be more than one that is. In this case, we only have one solution, and it is an extraneous solution because when you plug it in, it does not work. For example 4, we're given x plus 4 minus x over x minus 4 is equal to -4 over x minus 4. So our least common denominator here is the x minus 4. We multiply the entire equation by x minus 4, which means we're going to be doing x times x minus 4, positive 4 times x minus 4. The negative, well, here, let's do it this way. We're going to do the x minus 4 times negative x over x minus 4. And then we also are going to do x minus 4 times -4 over x minus 4. So with these, the x gets distributed in, so we have x squared minus 4x. Then we have 4 gets distributed in, so that's 4x minus 16. This x minus 4 and this x minus 4 cancels, so it's just a negative x. And then on the other side of our equal sign, the x minus 4 and the x minus 4 cancel, so it's just negative 4. We combine our like terms. The negative 4 and the positive 4x are opposites, so they cancel out. So we just have x squared minus 16 minus x minus 4. Oh, sorry, is equal to negative 4. We're going to move that 4 over, put it in standard form. So we have x squared minus x minus 12 is equal to 0. You want your factors of negative 12 that add up to be a negative 1. It's going to be 3 and negative 4. So this factors out to be x plus 3 times x minus 4 is equal to 0. For the x plus 3, set it equal to 0. X minus 4, set it equal to 0. Solve. We're going to subtract 3 from each side, and we get that x is equal to negative 3. We add 4 to each side, and we also get that x is 4. Check both of these solutions. If you plug in the negative 3 into the original equation, if you have negative 3 minus 4 in the denominator of your fraction, it gives you negative 7. You can work with that. However, if you plug in the 4 into any of those denominators, you get 4 minus 4, which is 0. And you cannot have 0 in your denominator. So this x is equal to 4 is an extraneous solution. So with these, I will ask you to identify any extraneous solutions for your answers, especially on a test or a quiz. For our next part, we are going to be working with equations where there's two fractions that are set equal to one another. When there are two fractions that are set equal to one another, you can cross multiply and simplify that way. It's the same exact thing as multiplying by your least common denominator. So in example 5, we have 20 over x is equal to 30 over x plus 20. So we are going to cross multiply here. We're going to do x times 30, which is 30x. Let's do it this way. 30 times x is equal to 20 times x plus 20. All right, so we said that 30 times x is 30x, and 20 gets distributed in, so that's going to be 20x plus 400. From here, we are going to subtract the 20x from each side. So that leaves us with 10x is equal to 400. We divide each side by the 10. Cancel out those zeros, and x is equal to 40. Again, check to see your denominators. 40 as a denominator works. 40 plus 20 is 60 as a denominator. That works. So x is equal to 40 is a solution. For your last example within this lesson, we have 2 over x is equal to x plus 3 over 5. So we are going to cross multiply with these. So we have 2 times 5 is equal to x times x plus 3. 2 times 5 gives us 10. X times x plus 3, we're going to distribute in that x. So that gives us x squared plus 3x. We subtract the 10 from each side to get everything on the same side since we have an x squared. We're going to be working with x squared plus 3x minus 10 is equal to 0. Find your factors of negative 10. That add up to be a positive 3. If we have a negative 2 and a positive 5, that gives us a positive 3. So this factors out to be x minus 2 times x plus 5 is equal to 0. Set each part equal to 0, so x minus 2 is equal to 0, x plus 5 is equal to 0, and solve for x for each. We're going to add the 2 to each side, and we get that x is equal to 2. We're going to subtract the 5 from each side, and we get that x is equal to negative 5. Check both of these. If 2 is in the denominator, it works. If negative 5 is in the denominator, it works. So these two are solutions.